Hey, hi guys, welcome to my channel. Welcome to yet another session of NumPy. Today we'll be discussing some of the mathematical operations which you can do on arrays and what else is in store for us to explore regarding NumPy arrays, right? Regarding the construction of NumPy arrays. So let's start right away. Import NumPy as np's, something which I have to do so that I can call the functions inside NumPy library. So let's say we have an array, say x is equal to np.array of a list, and I'll make it a list of lists so that I can get a two-dimensional array. If I have, say, 1, 2, 3, 4, 34, and here let's say whatever number it is there, right? And we also know that arrays can store only one type of data. So if I do this, I get a 2 by 2 cross matrix. Can I increase the dimension further? Because if I know that x dot shape is actually 2 cross 3, so it's a two-dimensional, because if I do x dot number of dimensions, we have 2. Now, what if I want to make it three-dimensional? Let's see. So if I do something like where I can add one more list to it, so I can get something like this, and this will make it a three-dimensional array. So if I say here any numbers, I'm keeping the number of elements same, which in each one of the smaller lists. So this is a three-dimensional array, and y dot shape 2 cross 2 cross 3. So this 2 means outer dimension, right? The main dimension. The main outer dimension has got two lists, this one and this one. So if I do y of 0, I get this, right? 1, 2, 34 and 4, 456, 7, which is till this point. If I do y of 1, I'll get the second half, right? So there are two elements inside this, inside the main list. Now inside one of the sub lists, again, I have got two elements. So if I do y of 1 of 0, I'll get the first row. How many elements do I have in the sub list? Again, I have got 3 elements. That is, this is what it represents, this tree, the last tree. This is the highest parent list. This is the second level list, and this will represent the lowest number of elements inside the lowest list, right? That is how the three-dimensional work. Now, why am I talking about 3 dimensions? I'm talking about 3 dimensions because whenever we read images in Python or in any programming languages, images, colored images are read as 3D arrays in Python. And these array data points basically consist of the pixel values of images. When you go to computer vision and we study convolution neural network, we need to understand how 3D matrices work. So basically, I'll show you one more example. Say x is equal to, an easier example rather, x equal to np.array of say 1, 2, 3, and I add one more element, say 4, 5, 6. Now this is two-dimensional because I know x dot name or x dot shape rather will give me 2 cross 3. But if I add one more list outside, which means that I'm going again in another level, I'm adding one more dimension to it. And this represents the highest dimension. In this highest dimension, there is only one element like this, right? Unlike in the previous array where I had one more list, within that again, 2 more lists. So this is what dimension means. So if we keep on adding one further list to it, you're increasing the dimension of the array. Now let's say if I construct something like this, and I have say one more lists, and I have 3, 4, 5. What about this? You can see here, the first element has a different dimension than the second element. And if I have a of 0, I'll get this. It has got 2 dimensions. Whereas a of 1 will have only 1 dimension because there is only one list as sublist. So here you get a warning. It will show the array, but if you want to convert it to some kind of a data frame or table, it's going to cause you some issues. So I have to import pandas as PD. Now, what has happened? It has created an issue. What is the issue? It has saved this entire list, the first element, as an observation inside that particular data frame. However, if I use the same array, okay, and make it two-dimensional, how do I make it two-dimensional? I'll use something like this. Say this is 2, 4, 5, and let's say I have 5, 6, 7, whatever it is, right? Okay, I need to add one more list to it. This is again three-dimensional. Data frames typically can store two-dimensional. So if I do PD dot data frame of the NumPy array, which is this, what does it say? Or data frame. Let's see what we get. Must pass a 2D input because this entire array is three-dimensional. So how do I make it two-dimensional? I have to simply remove one list away from it. Now I get a two-dimensional array or data frame. Because data frames are always two-dimensional. Arrays can take more than two-dimensional. It can be multi-dimensional, just like the one we saw just before this. So let's say D is an array, okay, say of 9 elements. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I know how to create, sequential elements, right, numbers, how do I do it? np.arrange. Remember, directly np.arrange, step size of 1 by default, 1, 10 will give me 1 to 9. This is how we automate stuff, right? And then if I want to change the dimension, so I have 9 elements. Can I make it 3 cross 3? Because total we have 9 elements, and in a 3 cross 3 array, we have again 9 elements, right? So if I do d underscore dot shape 3 cross 3, so total how much will we get? 9 elements, number of rows by multiplied by number of columns. Now, can I reshape it to other formats as well? 1, 9. 1, 9 this is again two-dimensional, guys. Please understand this. This is two-dimensional because you have one more list outside this list, right? So what will be the shape of it? 1, 9. Now I can also make it something like this. 9, 1. This is again two-dimensional. Now what's the difference between the two? Here the entire list is inside the first dimension, and here individual elements are within the dimension themselves. So we can think of a row versus column concept. 9 cross 1, and this is 1 cross 9. Whenever we have a number of elements, say I have 10 elements inside a list or a single dimensional array or list, whatever it is, I can reshape it to any size, provided the number of columns multiplied by the number of rows gives me that number of elements. So if I have 10 elements, I can either create a 2 cross 5 matrix or a 5 cross 2 matrix, or in fact, a 1 cross 10 matrix and a 10 cross 1 matrix. So basically the factors of 10 allows me to create that means that type of sizes of matrices or arrays. So let us take, say, 18 elements. Okay, what are the common factors of 18? So if I have 18 elements, let me just directly create the array. mp.arrange a single r, 1 is to 19 will give me 18. And then if I do x.reshape 1 cross 18, 18 cross 1 is always there. If I can shape it like this, say 3 cross 6, also I can do for 18, I can make it as 9 cross 2, 2 cross 9. Can I create 3 dimensions? Because I can do something like this, right? 2 3s are 6, and again 3, 6 3s are 18. So I can create 3-dimensional array also, not only 2-dimensional, but it has to be the total number of elements have to be a product of 3 numbers, which is 2, 3, and 3. So as the number of elements increases, of course, I can increase the dimension as well. So that is all for today, guys. So we talked about how we can change dimensions in arrays, and this will help you understanding the dimensionality concept. But when it comes to dealing with normal data frames or tables, typically they are obviously two-dimensional in nature. Even when we do machine learning or any kind of modeling, it generally takes in two-dimensional data. Okay, guys, hope this was interesting. Please subscribe to our channel, like and share. Thank you so much.